logic. Answer to deal with categorical propositions. Remember categorical propositions? Remember all that stuff you did for the midterm? Good times, you know. In fact, those were good times. Well, I hope you've remembered some of them because it will be relevant to what we're going to do now. So, why do we need predicate logic? Well, think of this argument. All frogs are green. Kermit is a frog. Conclusion. Kermit is green. Now the reason you know that is because this is obviously a valid argument, right? Well, if it's a valid argument, we should be able to show that by the truth table method. So first we would have to symbolize all the propositions. Well, we look through the sentences to see if there are any of our logical words like and or, and there aren't. So basically, this would just be a single letter. Let's say F. Same with this one. Kermit is a frog. There's no and, ors, ifs, or anything like that. So again, that would be a single letter. Let's say K. And then finally, same deal with this one. G, let's say. With the resources that we have so far, we would have to symbolize this argument like this. The trouble is that that is not a valid argument. That's easy to prove. I could make this true, and make this false. Bam. I proved that it's not a valid argument, because if it's a valid argument, that's impossible. So there's a problem here. This is clearly a valid argument. With the resources we currently have, we cannot capture the validity. We cannot symbolize it in a way so that it comes out valid. We need more tools to be able to symbolize it correctly. And that's what predicate logic is about. Predicate logic allows us to deal with the features of categorical propositions, all and some, all that stuff we learned before the midterm. Now, otherwise, it is an addition to the logic that we have learned so far. It looks different from it, but in some senses it looks the same. It uses all the resources. We will be doing ifs and ands and ors and all that business. We will even be doing proofs in predicate logic. Wouldn't that be fun? So it's just an addition to the stuff that we have already learned. Having said that, there is a slight alteration of the way we've been proceeding. So the way we've been proceeding is to take our component propositions, our simplest propositions, and symbolize them as a single capital letter. What we're going to do, but the trouble with that approach is it doesn't reveal what these two sentences have in common. Because they're saying different things, you would have to use a different letter to symbolize them. But what do these two sentences have in common? Kermit. What is Kermit to each of those sentences? The subject. Okay. So it would be nice if our new way of symbolizing revealed the subject of the sentence. Now, every sentence has two elements, the subject and the predicate, hence predicate logic. So each of those is going to be symbolized. All right, let's go over to this table that I prepared earlier. That introduces the four new elements in predicate logic: names, predicates, variables, and quantifiers. Let's focus on the first two of those for now. Names are going to represent the subjects of sentences. Well, some sentences, not all sentences, but where they feature, the name will represent the subject of a sentence. So, what names represent are, and you probably can't read this because my handwriting is terrible, so I will read it to you: particular, definite, individual, persons, places, or things. That's what names stand for. Now, this will include everything that we're used to calling a name. So Kermit, for example, will be symbolized using a name. But names in logic is a broader category of things. It includes proper things that we would call names like London, Kermit, things like that. But it also includes more than that. So for example, this chalk. If I say a sentence, if I were to say this chalk is white, that would be rather a tedious sentence, but it would be a sentence whose subject we would represent with a name. So this chalk functions logically as a name. Why?
It indicates just that one.
Yes, because this chalk is a particular definite individual thing. So you can represent it with a name. We will shortly come to examples where names are not appropriate, but clearly they're appropriate in that case. Now, what do we have? This column says what they stand for. So names, predicates, variables, quantifiers. What they stand for. Names stand for particular, definite, individual persons, places, or things. And the next column says how symbolized. How are they symbolized? The answer is they're symbolized with lowercase letters A through W. Not all at once, but you can use any letter from A through W as a name. So lowercase. All right, so that would represent Kermit in each of these sentences. So you would use, let's say, a little k to represent Kermit. Now, what about the rest of the sentence? Well, the rest of the sentence is the predicate. If sentences consist of subject and predicate, well, when you take out the subject, you're left with the predicate. And that's going to be the first way we think about predicates. Kind of a simple way of thinking about predicates. What is a predicate? A predicate is a sentence with a blank where the subject would go. So, in this sentence, Kermit is a frog. We've got the subject, Kermit, which, because he's a definite individual, we would represent with a name, a lowercase k. And then we have the predicate. The predicates are represented with capital letters. So in other words, predicates are now symbolized in the way that we previously represented the entire proposition. Like we used to use capital P's and Q's, and we still will for some purposes, to represent the entire proposition, but in predicate logic, we use that to represent the predicate. So in this case, let's say Kermit is a frog. I would use capital F to represent blank, and I'm going to make you say the blank for reasons that will become clear later, just because I like to make you dance. No, that's not the reason, but blank is a frog. That would be the predicate in this instance. All right, so how do we put it together? Well, we put it together in kind of an ass-backwards way, and it's ass-backwards in two respects. First of all, you put the predicate first. So Kermit is a frog, you would put the predicate first, followed by the subject. So it's kind of like Yoda speak. Is a frog Kermit, you say. Okay? That's how you write it. I don't know why that is, possibly because the inventor of predicate logic spoke German. His name was Gottlob Frege, and Germans do funny things with their sentences. But anyway, that's how you do it. The other aspect with respect is, of course, we normally think of names as capitalized, but now names are the lowercase ones. So Kermit becomes lowercase k, and the rest of the sentence, blank is a frog, becomes a capital F. So how would I symbolize Kermit is green? Capital G, little k. So right already we can see an advantage of this new way of doing things. It reveals that these sentences, although different, have something in common. They're both about Kermit. Okay. That's the first element, the first two elements of predicate logic. Let's get you used to those by doing some examples. Turn to page 407. Practice quiz 14.1. Nick, start us off. So what I want you to do, first of all I want you to read the sentence. Then I want you to identify the predicate or predicates that you will need. And then I want you to symbolize it.
Opus is board.
Tobias.
Tobias is board.
I can't think of that name as anybody else but Tobias Funke, now that I've seen Arrested Development. If you don't know who I'm talking about, I pity you.
So would that be big B T?
What does the big B stand for?
Big B would be board.
That's an incomplete answer. Give me a complete answer. Blank is bored. Blank is bored. So I want the whole sentence plus the blank where the subject would go. So big B stands for blank is bored. It's a predicate, and of course Tobias we do with a little t. So it would be BT, like that. That's right. Okay. Number 2, something that bemused us on the other side of the Atlantic.
President Reagan was popular. Predicate B was popular.
Sorry, what was that?
Blank was popular.
Thank you. Blank was popular, so what should we use for that?
Capital P.
Yeah. So capital P for blank was popular.
The solar system.
Wait a minute.
Oh.
Zach's not finished. What's the whole thing again? Did you say what the whole thing was?
I guess it would be little p.
Oh, yeah, or little r, it doesn't matter. Yeah, you can use the same letter because predicate logic is case sensitive. So little p will not be confused with big P. So how would you symbolize the whole thing?
Big P.
Big P, little p. That's right. Big P, little p, what begins with P? All right, number 3. Brian.
The solar system is billions of years old. Big O is blank is billions of years old.
Uh-huh.
And then little s, the solar system, and then it'd be big O sub s.
Yes, that's right. Big O, little s. So the solar system is, you might not think of that as a name, but logically it is, because even though it's a massive, a massive entity that consists of millions of other things, it's still a definite item that we can name. So that's right. All right, number 4, Destiny.
What car is the most likely? What car is the
Now, here, we can think of this as, well, what is the logically relevant word that we talked about before this chapter in that sentence? And, yes. Destiny threw her voice on that. And, that is correct. So it is 2 propositions. So in one sense, you can think if it's 2 propositions, there will be 2 predicates. What are the 2 predicates? All right, what are the 2 subjects? Yes, so my car is the subject of one. What is being said about my car?
The name of it?
What's that?
What kind of car it is?
Yes, so the predicate is blank
Volkswagen.
is a Volkswagen. So let's say capital V for blank is a Volkswagen. Is a VW. And what is the other predicate?
Rose.
Well, be complete. It's not just one word. What is the whole thing?
Blank is a
Yes, blank is a rose. There's a reason for me insisting on saying the blanks. As I said, it will become clear later. All right, so we have 2 predicates and we have 2 subjects. What are the 2 subjects?
My car, his car.
So what should we use for my car?
Let me see. Let me see.
No, just one letter. So how about little m?
Okay.
Yeah, you can't use 2 letters. Blank is my car, and then his car,
H.
little h. Okay, so the whole thing comes out as what?
Capital B, little m, and
Broke my chalk.
capital R, little h.
That's right. Yes. Okay. How about number 5, Eric?
Monaco is either a big city or a small nation.
Yes,
Could
it is.
be, blank is either a big city.
No. Either is associated with the word or. So it's not going to be built into the predicate. So you have got a proposition there that will have or in the middle of it. It's going to be something or something else. Okay, so what are your predicates?
Big city. and-
Wait a minute, what did you say? Let's say C is,
Blank is a big city. And then big N is blank, a small nation.
yes.
And then little m is Monaco.
Indeed it is. All right, symbolize away.
MC or no, C,
Well, let me interrupt you. You might be tempted to do it this way. But you can't. Okay? You might say, well, we're talking about Monaco and we're saying that it's either a big city or a small nation. You can't do that. You're not allowed to do that. The reason you're not allowed to do that is you can never have either a predicate or a name by itself. So you can never have a predicate like this. That is incomplete. You always have to have a big letter and a small letter right next to each other. You cannot have the predicate without immediately attaching it to its subject. So how are we going to do it then?
CM or N.
Yes, very good. Now notice, of course, in the original sentence, the word Monaco only occurred once, whereas here we've got Monaco occurring twice. Doesn't matter. That's just how you're going to... They're just 2 different ways of expressing the same information. To express the information in the English, you have to use M twice when you convert it into logic. Okay. Number 6. Jordan.
If the English speaks, I listen. I think capital I, little g, then capital I, or capital L, little I.
So, what am I doing? Okay, S, D, then L, I. So S stands for?
Blank speaks,
L stands for?
listen. Blank listen.
That's right. And D is Dean Witter, obviously, and I is I. That's right. That's exactly right. Okay, Samantha, something I hear all the time.
I'm confused and you're not helping. The subjects would be I and you, and predicates would be.
Wait a minute, so little I for I, how am I going to symbolize you? No, I can't do that. Why can't I do this? Yes. Guess what I'm saving X, Y, and Z for?
Variables.
Variables, yes. X, Y, and Z are going to be variables, so you can't use Y for a name. So let's just use U. Why not? Actually, later on, But a few classes on, I'm going to reserve U for something else, but never mind that now.
And then the predicates would be C equals blank is confused.
Yep.
And then H is blank is not helping.
No, I'm not going to allow that either.
Or is it like a tone?
What's that?
Is it a tone?
Yes, so H stands for
Not
no?
or not.
Yes. Well, stands for blank is helping. Yes. Yeah, in other words, I'm not going to let you build the not into the predicate. We're going to symbolize that using the tilde. Okay, so finish it up.
So then it would be capital C, little I, and tilde, capital H, capital U.
Exactly right. Okay, I think we get the basic idea there. Oh, let's just do number 8. Jake.
If we win, we'll either go dancing or go to a movie. So we could do like big D is blank.
Yes?
Go dancing.
Yes, it's always going to be slightly artificial because do you say go or goes? Well, it depends on what's going to go there. If it's we, it would be goes. So there's a certain amount of speaking like a caveman when you're doing predicate logic. So just say go dancing. And if it's, I, then it's I go dancing or whatever.
Or we.
Okay.
And then big M equals blank. Go to movie or go movie.
Blank go, I go movie. Go, you can't actually say to there. We'll allow that.
Go to movie.
Go to a movie.
Go to a movie. And then little W. Oh.
What?
For win?
No, that
We,
would be
yeah.
we.
Wait.
Well, so big W would be for what?
Oh, blank.
Wins.
Wins.
Okay. Symbolize.
So you do like if big W, little w,
Yep.
and then like arrow, big D, little w, B, and then big M, little w.
Do I leave it like that? Yeah, I need parentheses because we have two connectives.
Yeah, so you put parentheses around the W, or the D of W and the M W.
Yes, because you know that the whole thing is a conditional because the first word is if.
Right.
So if we win, then one of these two things will happen. Yeah, so in other words, it's just like regular logic, only split into two parts. Except, this is where it gets a little bit tricky. So, we know how to symbolize Kermit as a frog. We would symbolize that as big F, little k. And we know how to symbolize Kermit as green, big G, little k. How do we symbolize all frogs are green? Could we do it like this? Big G, little f. If we did it that way, what would the little f stand for? Yes. Can we use a name to represent all frogs?
No.
No, because names have to refer to particular, definite, individual persons, places, or things. All frogs is not an individual. So we can't do that. So if we're not going to use a name to represent the subject of a proposition, there is only one other thing you're allowed to use, and that is a variable. So names and variables are the two ways of symbolizing the subject. If you don't use one, you have to use the other. Okay, so what does a variable look like? It looks like what? x, y, or z. Little x, little y, or little z. We won't need either y or z for a while. Just x will be fine for today. But later on we will need more than one variable. Okay, so what does a variable represent? Variables represent non-specific entities of a number to be determined by an associated quantifier. So, names represent definite entities, like Kermit. Variables represent non-specific entities, like some frog or other, or something. Basically, you can think of a variable as standing for a thing. It is non-specific. What's that?
What's the last word in the definition?
Quantifier. And quantifiers are the next thing I'm going to introduce. Alright, so there's a footnote here. So variables are non-specific entities of a number to be determined by an associated quantifier. Footnote. Down here. Golden rule of variables. Write this in blood, because it's very important. That should be the bloody rule of variables. No variable is allowed outside the scope of a quantifier. I will explain exactly what that means in a second. No variable allowed outside the scope of a quantifier. So just as you can't have a predicate without a subject immediately attached to it, you cannot have a quantifier, you cannot have a variable unless that variable is what's called in the scope of a quantifier. Now, what are the quantifiers for? Well, they're to establish the quantity. How many quantities are there? Cast your mind back to when we did categorical. 2. What are the 2 quantities?
All and some.
All and some, that's right. So that's how many quantifiers there are. There's the universal quantifier. And what would the other quantifier be called? Particular. You'd think so, wouldn't you? But in fact it's called the existential. Now there's a reason for that. We'll get to that in a second. But yes, there are 2 quantifiers. There is the universal quantifier. What does the universal quantifier stand for? It stands for all ... By itself that makes no sense, which is fine because quantifiers by themselves make no sense. They only make sense in the context of a larger proposition. Like predicates, they cannot be isolated and make sense. They only make sense alongside other things. The other one is called the existential. Now, why isn't it called the particular? Well, it could be called the particular, but there's a reason why it's called the existential. Where have we come across that word existential before? It was along with another word.
Import.
Import. Do you remember when we talked about existential import? I wouldn't hold it against you if you didn't. It was in the context of talking about unicorns. Do you remember when we talked about unicorns? I asked you this question. I said, every proposition has a truth value. That is just an assumption of logic. Every proposition is either true or false. So what is the truth value of all unicorns have horns? It's true. Why might you worry about saying that it was true? Because unicorns aren't real. So what? Well, we have a tendency to assume that if you say that it's true that unicorns have horns, in a sense you're implying that there are unicorns. That is what existential import means. It means the implication about existence of particular propositions. So the worry is, all unicorns have horns can't be true, because if it were true, it would imply that there are unicorns and there aren't. Well, the way that modern logic, when we discussed this, it was to illustrate the difference between modern logic, illustrated by Venn diagrams, was different from classical logic. And according to modern logic, universal propositions do not have existential import. And this is kind of obvious from the Venn diagrams. What is the Venn diagram of all SRP? Am I shading or putting an X? What region? 1. 2 would be no SRP. Yeah. So suppose this is unicorns and this is things with horns. Is this in reality true? This. The answer is yes, it is. Why? Why is it in reality true if S represents unicorns and P represents horned beasts?
Because that's what
All of
makes
that's
it unicorn.
That's not saying that there are anything in, that there's something in two. It's just
Yeah, because what does shading represent? Emptiness. So this is just saying, this isn't, I mean, in effect what this is really saying is that there aren't any unicorns without horns. And that's true because there aren't any unicorns. There aren't any unicorns with or without horns. So this is saying that the set of unicorns without horns is empty. Well, yeah, because there aren't any unicorns. So this is true, but it's true because it doesn't have existential import. In other words, it's not saying that anything exists. It's saying that something doesn't exist. Whereas, contrast that with some unicorns have horns. How do we illustrate some unicorns have horns? Put an X. That has existential import, right? Because X represents something that exists. So consequently, particular statements we call existential now, because their truth implies that something exists. And in fact, the definition of existential quantifier is there exists at least one ... such that ... Again, it doesn't make much sense out of context. But the word exists features prominently. So when you use the existential quantifier, you're saying that something exists. Whereas in the universal, you're not. Okay. How do we symbolize these quantifiers? Well, first of all, they both come surrounded by parentheses. The second very important feature is you have to include within those parentheses the variable that the quantifier applies to. Because remember, over here we have this golden rule of variables. You can't have a variable outside the scope of a quantifier. Well, sometimes you can have two different variables within the scope of a single quantifier. But the single quantifier can only apply to one of those variables. And you have to indicate which one it is. So let's say it's x. Could be x, could be y, could be z. But whichever one it is that this quantifier applies to, that has to be included within the parentheses, so that you can then look along the line and find that variable that this applies to. Finally, there has to be a way of telling which quantifier it is. They can't both look the same. So for existential, it begins with E, but just E would be very boring. Tell you what would be cool is a backwards E. That would be awesome. And in fact, that is the symbol for existential quantifier. In parentheses, backwards E, X. So consequently, you need to search through your wingdings in your fonts to find that thing. Now, don't write this, but if we're going to say universal stands for all. So it'd be nice if we had an A in there, but we can't have a regular old A, that would be boring. And you can't have a reverse A because it's the same as a regular old A. So this one they turn upside down, except, that's why I said don't write it, they don't do that anymore. They notice that you only need one of these things. You only need a way of distinguishing between these two, so you don't need a symbol for both of them. So the way they do it in this book is the universal quantifier is just the variable in parentheses. The existential quantifier is the variable in parentheses plus this weird backwards E. That's the way you tell the difference. If you come across an upside down A when you're perusing philosophy journals in your spare time, well, now you know what it stands for. But we're not going to use it in this class. All right. Now, no variable outside the scope of a quantifier. How do we work out the scope of a quantifier? Easy. Quantifiers work just like tildes. So, suppose I wrote this, not P then Q. what is the scope of this tilde? It just applies to P. If I wanted it to apply to the entire line, what would I have to do? Put parentheses. That's right. So that's how you determine the scope of a quantifier. So, if you saw something like this, is that allowed? So we have existential quantifier px and qx. Is that allowed? No, it violates the golden rule. Why does it violate the golden rule?
Because X is being used in both P and Q.
That's not the reason. That's okay.
So there's a variable outside of the line.
Yes, which one?
PX and Q.
No, px is not. Px doesn't violate the rule.
But isn't
Qx violates the rule. Px is in the scope of this quantifier, but Qx isn't. Because remember, it works just like a tilde. Unless you have parentheses, this quantifier just applies to what it's right next to. So how would I solve this? Two ways. I would either make sure that the scope of this quantifier applies to here, and I would use what? Parentheses, so that would be one way. That would mean one thing. Alternatively, something that would mean slightly different, but might also be correct, is if I had a second quantifier here. And I can even use the same variable because this quantifier is outside the scope of this quantifier. So this would be, say, something is P and something is Q. Yeah, in fact, what's the difference between these two? What's the difference between that one and that one? This one where we have two quantifiers and this one where we only have one. Yes?
On the first one, X doesn't, well, it's going to be anything, or
It's going to be, there exists at least one thing.
yeah, there exists something, and that thing doesn't necessarily have to be the same between P and Q.
Yes, so this would be saying something is P and something is Q. Not necessarily the same thing. What does this say?
Some
Did the
one
same
thing
thing.
is both P and Q.
You would be saying that there is one thing that, and that one thing is both P and Q. This one, you know, I could say, so suppose this is P stands for is red all over, and Q stands for blue all over. One of these could be true. Which one could be true and which one couldn't?
First one could be true, second one would be false.
Right, because the first one says something is red all over and something is blue all over. That's possible, so long as they're not the same thing. But this one says something is red all over and blue all over. That's not possible. Does that make sense?
But so are they different?
Yes, they're saying two different things.
But isn't the variable like what's describing something like that? Something like something. If you can use.
But
just like
this is a different thing because the only way you would need a different letter, like, you know, you could write this as well, using a different variable. But you don't have to in this case because the scope of this one ends here. So you can reuse X to stand for something different. Even though it's in the same line, it's outside the scope of this one. So it's a new thing. Okay? If it confuses you, it's fine to use a different one. But you only have to use a different one if this was in the scope. Suppose I wanted to say, to have this be in the scope of this one, but this one referred to something different, then I would definitely have to use a different variable. Because now this one is in the scope of this quantifier, but it's talking about something different.
It's saying like something is X and something is different X.
No, when you're saying something, the X stands for something, and then the is refers to the quantifier. So you're not saying something is X,
Okay,
you're
okay.
saying something
So-
is P.
Okay, I got you. So like the X remains like constant for.
Variables just stand for things.
Okay. So just
All right. Now,
9.
suppose I wanted, a couple of points before we go any further. When I say universal, I mean it. So when you use the universal quantifier, you are referring to everything in the universe. So I'm going to Alright, so suppose G stands for is green. Okay, we've already used that, so why not use it again? Is this an allowable proposition? No, it is not. Why not?
Doesn't have a quantifier.
It violates the golden rule. It is a variable without a quantifier. Alright, let's add a quantifier. Now that's perfectly grammatical. What does that say? Or what does that mean?
Everything is green.
And when I say everything, we mean everything in the entire universe. Okay, whereas if I say this, that means something is green, or there exists at least one green thing, or there are green things. All of those are pretty much are equivalent according to the tools we have at hand. Okay? So far so good? Alright, now we still don't know how to symbolize all frogs are green. So perhaps the simplest way to go about this is to remind ourselves of the categorical propositions. How many types of categorical proposition are there? What's that again, everybody? 4. They are A, E, I, and O. In words, what is an A type? All SRP. What is an E type? No SRP. What is an I type? Some SRP. Some SR sneeze. What is an O type? Some S are not P. Okay. Now, we know already a difference that we're going to see when we're going to symbolize each of these using predicate logic. What's going to be the difference between the ones on the top row and the ones on the bottom row? What's that? Quantifier. On the top row we're going to use universal quantifier. On the bottom row we're going to use existential. Okay. Let's start with an I type. Some SRP. Now, let's get one slightly confusing thing out of the way immediately. What does S stand for? Subject. What does P stand for? Predicate. How many predicates are there in this sentence? 2. Why? Because both of these are predicates, even though one of them is called the subject. So the subject is a predicate. That's pretty screwy. Why? Well, because what we're now calling predicates in predicate logic was pretty much played, the role of those were played by what I called categories when we did categorical propositions. So both S and P are categories. Okay? So both of them are going to be symbolized as predicates. So if I say some SRP, let's say I'm saying some socks are purple. I've seen them. Okay, how would I symbolize that? First of all, I would be saying, first of all, my subject is going to be what? A name or a variable? It's going to be a variable. Why is it going to be a variable? Because it's non-specific. I'm not talking about Joe the sock, right? If I was talking about Joe the sock, a particular individual sock, I would use a name. But I'm just talking vaguely about some socks. Socks I haven't even met. Okay? So it's going to be a variable. Now remember, what does a variable stand for? What is a variable? It's a thing. It's not a sock, it's just a thing. Now I'm going to say of that variable that it is purple. Right? But what also do I have to say about it?
It's a sock.
I have to say that it is a sock. Because variables are not automatically socks, they're just things. So if I want to say that this thing is a sock, I have to say that. So its suckiness becomes a predicate. becomes a feature that it has. All right, now I've got the two elements. I've said that X is both a sock and it's purple, but that by itself fails in two respects. What is one respect in which that fails? Doesn't have a quantifier. Now which quantifier are we going to have? Existential, because it's some socks. And of course it has to apply, this is the same thing that we're talking about. It's both a sock and it's purple. So it has to be, we have to put parentheses around it to say that this quantifier applies to the whole thing. Finally, what is the connective going to be? It's going to be and, because I'm saying that it is a sock and it's purple. So that is how you symbolize an I-type. Basically, you are learning a new language. We can call it predicates or logicese if you like. And predicates is a very simple language. It just talks about things and their properties. So, and you write it like this. What does this say? There exists at least one thing such that that thing is a sock and that thing is purple. That's what this says. Then you have to say, does that convey the same information as this sentence in English? And the answer is yes. So in other words, this is the best way to represent this letter in English. But of course, if you read this through, in logicese, it would be saying something much more cumbersome. There exists at least one thing, such that that thing is a sock and that thing is purple. Some socks are purple. Remember, if you like, remember how we represented some SRP as a Venn diagram. Looks like this, right? What do we say? We're saying X is S, and we're saying that X is P. So XS and PX. All right? Now let's work out how we symbolize some S are not P. That's what it would look like in the Venn diagram. Who thinks they know without looking at it in the book? Josh.
There exists an X.
So, back, existential quantifier.
Such that SX and not PX.
Who agrees? Yes, that's right. There is something, that thing is S, and that thing is not P. Some S are not P. Good, so that's how you would do an O-type. All right, now let's move on to the universals. So in these, we're going to use the universal quantifier. And you might assume that you would write this, but don't write it yet. But in fact, this doesn't say what we want it to say. What does this say? All things are both. Yes. So what this says, in fact, is everything in the universe is a purple sock. We don't want to say that. We just want to say of all things that are socks, that they're purple. How do we fix this? Yes.
Do like SX, like big S, X.
It's a very simple fix.
S,
Yes,
just-
Brandy.
So take the parentheses out?
No, because then that would be outside the scope of a quantifier and that wouldn't be allowed.
Distribute the X.
That's too complicated. I don't want to say everything in the universe is both a sock and purple.
We get that.
Yes. Instead of an and, we want the conditional. So, what does that say? That says for everything in the universe, if it's a sock, then it's purple. It doesn't say everything is a sock and it's purple. It says for everything in the universe, if that thing is a sock, what do we know about it? It's purple. If it's not a sock, screw it, we don't care about it. That's how you do universals. So when 9 times out of 10, when you see the universal quantifier, you know that if there is a connective in the scope of it, that connective will be a conditional. If you see the existential quantifier, 9 times out of 10, probably more than that, the connective in its scope will be the ampersand. Now, there isn't always a connective. If you just got one predicate, if you say something stinks, you would just say there exists at least one thing, and it stinks. You wouldn't need 2 predicates. But if you say some cheese stinks, then you have to say if the thing, because you're not just talking about thing, you're talking about cheese, you would have to say there exists at least one thing, it is cheese, and it stinks. Now, so, the upshot of this, one upshot of this that is very relevant to your homework, is there is a big difference between these 2 sentences. The cheese stinks, and a cheese stinks. Or the cheese is stinking. Let's do it that way. The cheese is stinking. A cheese is stinking. What is the big difference between these 2? What's that?
First one's particular.
The first one's particular. So how are we going to symbolize the cheese? We're going to use a name. So we're going to say little c, and what is true of little c? It stinks. So the predicate blank is stinking applies to it. That's it, we're done. That means the cheese is stinking. But a cheese is stinking. What's the difference between the and a? Anybody know their names as parts of speech? One, they're different articles. One is the definite article, and the other one is the indefinite article. Which one is the definite article? The. And because it's definite, you use a name. So the cheese would be a definite individual thing. Which cheese? You know, the cheese. So that one you use a name for. Whereas a cheese is indefinite. If it's indefinite, you can't use a name for it. You have to use a variable. So, you would say, let's say we use the variable x. You have to say x is stinking. Can I leave it like that? No. It fails in oh so many ways. One way it fails is the golden rule. So what do I need? I need a quantifier. Now, of course, the trouble with the word is that sometimes it's universal and sometimes it's existential. Remember the difference between a whale is a mammal. What type is that? A, E, I, or O? A whale is a mammal. It's an A. It's a universal. I'm saying all whales are mammals. But a whale beached itself in San Francisco today. Which type is that? That's an I type. So that's why I said a cheese is stinking. Which would this be? Universal or existential? Existential. It's a cheese. It's not all cheeses, but it's not a definite cheese. It's just some cheese. A cheese is stinking. I couldn't tell you which one. It's a gorgonzola. Okay. So I'm going to use the existential quantifier. If I left it like that and moved them closer together, that would be perfectly grammatical. What would it say though? Something stinks, or something is stinking. But that's not what I want to say. What do I want to say? A cheese stinks. So what do I have to add? I have to say that X is also a cheese. So it becomes an I type. This is an I type. Notice the big difference. There's a whole other predicate here. Why do you need the predicate here where you don't need it here? Yeah, I mean, the difference is because here you're using a name, and there's a difference between names and variables. Names can have information built into them. So if something is called the cheese, it kind of gives it away that it is a cheese, right? But whereas a variable just stands for a thing. So the information that it is a cheese is not built into it. You have to add that information using a predicate. Now, if you go back to your little, let's briefly get this out of the way. If you go back to this, when I defined a predicate, I said it was a sentence with a blank where the subject would go. That's one simple way of thinking about it. Perhaps another slightly more sophisticated way of thinking about it is that predicates are properties. So, that perhaps clears up the confusion here. When you're saying a cheese is stinking, you might think, well, the subject is a cheese, so the predicate is blank is stinking. There's only one predicate there. But when you've got to think about it in logical terms, you're thinking, okay, I'm saying something exists. I'm saying something exists. How many features does this thing have? It has two features. It is a cheese and it stinks. So I'm going to need two predicates because there's two properties involved. That's why S and P are both predicates, because they're both properties. One way of saying that something has a property is to say that it is in a group of things. You have the property red if you're in the group of red things. You have the property of being a cheese if you're in the group of cheeses. Okay? So whereas before in categories we thought in terms of groups of things, here we're just going to think in terms of properties. Another kind of advance that this way of dealing with categorical propositions gives us is actually, we had to do something rather artificial when we were talking about categorical propositions before. How did we deal with proper names, like John F. Kennedy? We treated them as universals. With a universal, we treated them as universals talking about a category of one. So when it said John F. Kennedy was not successful in his domestic policy, we had to turn that into all John F. Kennedys are things that are not successful. It was very kind of artificial. We don't have to do that anymore. Because if you're talking about JFK, you just use a name to refer to him. You don't even have any quantity. You don't need a quantifier. So it's a lot more intuitive, this way of doing things. When you're talking about specific individuals, you don't even treat them as involving quantities. You just use a name. So that's good. All right. So, oh yes, we haven't done E yet. No SRP. What's that going to look like, Jake?
X.
The universal quantifier?
Yeah, universal quantifier, and then like bracket S, X, then not PX.
Yes. For everything in the universe, if it's an S, then it's not a P. What's the difference between these two things? Suppose G is green. So this says everything is green. Then suppose I say this, and also suppose I say this. Are they saying the same thing?
No.
No, they're saying two different things. What is this one saying?
Nothing's green. Or not green.
It's saying nothing is green because, well, what does it in fact say?
Everything is not green.
Everything is not green, which is another way of saying nothing is green. What's this say?
Not everything is green.
Yes, not everything is green, which is another way of saying some things are not green. This says nothing is green. This says some things are not green. Okay? All right. Now, let's do some exercises. Turn to page 412. Who did we get to? Jake, did you do one? Yeah, I think you did. Zainab. There are ghosts. Well, when you're saying, first of all, tell me what predicates we're going to need. We're only going to need one. What is the predicate that we'll need? Or G for blank is a ghost. Thank you. Blank is a ghost. All right. Now, we're going to be using a name or a variable. Why?
Because there are ghosts.
We're not talking about specific. We're not talking about Casper or anything like that. We're just saying we're saying ghosts exist. So it's going to be a variable, and because it's a variable, we need a. What does every variable have to have?
Quantifier.
Which one?
Inverse.
If it was universal, what would we be saying?
Everything is.
Everything in the universe is a ghost. We don't want to say that. Existential. So what this says in logic is there exists at least one thing such that that thing is a ghost. Does that say there are ghosts? Well, it says that ghosts exist, or at least one ghost exists, and that's good enough. So that means there are ghosts. Okay? Now that one doesn't look like any of the four types. Because there's only one predicate. But most of the others are going to involve more than one predicate. So they're going to be one of those types. So perhaps the easiest thing to do is just identify what type they are, and then you've got the basic form already laid out for you. So Brandy, all skyscrapers are buildings. A, E, I, or O. A type. So you know it's going to look like this. You just have to fill in the blanks. What goes here and what goes here. Yes, so S stands for blank is a skyscraper, B stands for blank is a building. For everything in the universe, if that thing is a skyscraper, then that thing is a building. All skyscrapers are buildings. That's right. All right. Some buildings are skyscrapers, Hunter. What type is that?
I.
That's an I type. So you know it's going to look like this. Existential, and the main connective is going to be an and. You just have to fill it in.
Big B, little x, and big S, little x.
That's right. Let's jump ahead to number 11. That's a bit of a jump, but you can handle it, Don. Now,
My children are married or engaged.
I would hope not. What type is that? A, E, I, or O?
E.
It's E. Now, the tricky part is that there are, of course, 3 predicates here. What are the 3 predicates? Blank.
Blank is my child.
Blank is a child
married,
o' mine. Yeah.
And blank is engaged.
Blank is married and blank is engaged. Now, but it's still going to have the basic structure of an E type. So it's still going to look like this, except, and this is going to be the main connector within parentheses, but there's going to be 2 predicates on one or other side of this. So what do you think it's going to look like?
I'd say.
Oh, and by the way,
yes.
because it's an E type, sorry to interrupt you, the tilde is going to always come immediately after the conditional.
If that something is my child, so CX, then it is not, opening parenthesis, MX or EX.
That's right. So notice that actually this way of doing things is rather flexible. You're going to keep the same basic structure even when the sentences are quite complicated with lots of predicates. So for example, all frogs are green is going to look, or all socks are purple looks like this. But suppose I wanted to say all woolly Christmas socks are purple and itchy. It would still have the same basic structure. It would still look like this, but instead of just saying socks, it would say that thing is woolly and a Christmas, and for Christmas, and a sock, and I would have to make sure that I have enough parentheses there. Does that make sense? Because I have to, I can't have 2 ands. I put parentheses around here, and then I also have to separate that. So that's woolly, and for Christmas, and a sock. Then it is purple and itchy. So you can basically just keep on adding properties using conjunctions. So What are we talking about? We're talking about something that's woolly and it's for Christmas and it's a sock. What are we saying about that thing? We're saying that it's purple and itchy. But the basic structure is an A-type. That should do it for now. So, remember, do your homework, look at the homework. If you are struggling with it, by all means email me and ask me questions. But don't forget to do it. And make sure